Okay, here we are on track 10. All right, so in a particle, two have charges have, this is a positive, and they're separated. Q1 has a charge of 2.1 times 10 to the 6 microcoulombs. They are separated by a distance of 0.37 meters. And particle 1 experiences an attractive force of 2.9 newtons. What's the value of Q2? Okay, with its sign. Okay, so so here's the deal, and I'm not going to work this out because you have the formula for it. R is equal to 0.37 meters. You should, I'm going to, Q1 we don't know, but Q2 was what, 2.8, something like that? Oh, Q1 we do know is 2.8 microcoulombs. Q2 we don't know, but it's an attractive force. So let's just put this positive force positive charge right here. Okay, let's just put this positive charge right here. 0.37 meters away, I've got another charge Q here. And it's an attractive force. Okay? This experience, it's being pulled, this is the force on 1 caused by 2, and this is the force on 2 caused by 1. Their absolute values are equal to each other. They're opposite, but of the same magnitude, but in opposite directions. Okay? So, they gave us F. We know that F is equal to K times Q1 times Q2 over R squared. Well, they gave you F, you know K, you know Q1, and you know R squared. Do you think you can solve for Q2? I think so. Let's move on. But you see how it works. You see what the idea is behind it. What's the next one? Because that's all we're going to do is I'm going to finish you out with the two are separated by a distance of 1.6 times 10 to the negative 3. The objects are initially electrical neutral and are very small compared to the distance between. Okay, so we don't have to figure out what the center of their mass is. Okay, the same negative charge, each object acquires the same negative charge due to the addition of electrons. As a result, each experiences an electrostatic force that has a magnitude of, okay, so we got another, how many electrons did it take to produce the charge on one of these objects? Okay, so how many electrons? Oh, we've got to figure out what Q squared is, take the square root of it, because they got the same charge. And the magnitude of the charge is 1.67, so we're going to 1.76, so we're going to do everything in, I love this problem. This is a great problem. All right, so let's look at problem 9 real quick. Problem 9 says this. Okay, so I've got two objects that are distance r apart. Okay, and they both develop a negative charge. Well, the force, this is this is sphere 1, and this is sphere 2. So the force on 2 caused by 1 is going that way. The force on 1 caused by 2 is going that way. So they're repelling each other. But let's just take the magnitude. So we know what F, again, they're going to be the same. So let's just take the force that's given. And since I know that the Q1 is equal to Q2, I'll just say that they're Q. So I got Q squared over R is equal to that magnitude. And you just solve for Q. This was the crux of the problem. I probably shouldn't have told you that. Stole your thunder. Let's look at problem 13. Ooh, this one looks like we might have to think about this one for a minute. So let's go ahead and stop here and let me think about it for a minute, and then we'll come back and look at it. Oh, I got to quit first.